Welcome back, everybody. Today we're going to be looking at a little bit different of a game. This is called While True, Learn. I was actually given a free Steam code by Mr. Oleg Chumakov recently. He is from Luden.io, and he also has participated in some different game jams. If you were to go to his Twitter, you would see that he has worked on V-Robot, AR Rive, AI Draw, InMind, InCell, InMind 2, Prime World, and he has some stuff on gamesjam.org. But yeah, so he had recently reached out to me with a code for this game, which is in early access, and I figured I'd give it a shot and let everyone know kind of what my impression of the game is. Now, because it is in early access, I'm sure it's going to be missing some features and things won't be quite polished just yet. But from what very little I've seen of it from the press packet I got that has some little videos and things in it, and I think there's some stuff on YouTube already. But anyway, from what little bit I have seen of it, it looks pretty interesting. If you've ever played Human Resource Machine, which is also on Steam, it looks to be sort of in that same vein of video games. So here we are at the main screen. Gonna check out settings real quick. I'm not expecting much in here. So we can disable tutorials. We got a colorblind mode because you're dealing mainly with, I believe, red, blue, and green for the main components of the game. You'll see that. So we got sound volume, music volume. There's some controls. I don't think they're gonna be that important. You can pretty much just do everything with the mouse. But we can increase and reduce speed of the time. We got a pause, show hide modifications, copy and insert the nodes you point at. Insert without lines, which could be helpful, but you can move those around pretty easy. Deletes blocks you point at, and deletes a line that you point at. I'm not sure what community does. It probably goes to either his Twitter or possibly Luden.io. Have not tried it yet. I may take a look at that later after the video. And you can load a new game, or continue from where you left off, and obviously exit. So we're going to go ahead and do a new game. Oh yeah, so as you can see, I did play the game a little bit, but I had gone back and I reset the tutorials and deleted my old game, but I guess it kept a checkpoint in there. So we're going to go back all the way to the beginning for tutorial. Let's get ourselves named in here. Hello friend, glad to see you in our game. So just got a little note here from the developer because we're still in early access. Alright, so here we are in sort of the main screen of the game. Oh, and I guess you can click the cat and it meows at you. Okay. I don't think there's anything else here that you can do. Nope. So one critique I do kind of have about this interface is you've got this sort of green-gray background up at the top, and you've got green lettering, and even the ones with the gray boxes around them, it all just sort of blends together a little bit. It's maybe not the prettiest UI design. And as you can see, these aren't buttons here, but this one is, and this one's not, and some of the, the UI isn't super, I mean, it's consistent, but, like, you would think maybe this is a button because it's got the same gray background as these other ones. Although, I guess it's more opaque, or, the buttons are more opaque than these ones, which are just informational. But yeah, just some little things, just sort of, I guess, talking out loud about what I see here. So, we've got mail here. This is where we get our jobs. And from what I can tell, at least in the tutorial beginning part of the game, you basically never come back out to this main screen. You just go from task to task, and as soon as you complete a task, you basically just get a continue button, and it automatically sends you into the next job that's available. So I don't know if that will change once I get out of the tutorial section. So yeah, if we go in here to mail, You can see this is task number 0. It's labeled school problems. I need 100% accuracy and I have 35 seconds to complete it. And I'll show you how the gameplay works in just a moment. Startups, I believe this is something that you create that basically earns you money in the background. But I think you'll make something like a program or whatever, and then you'll set it in the back. Oh, I know what it is. The game dev tycoon. That's what I'm trying to think of. Where you basically create a game or a console or whatever, and over time it'll make you money while you work on individual jobs for your income between creating large startups, as this game is going to call them, it looks like. And then we have private mail. I'm assuming things like special job offers or possibly special things you can purchase or something like that will pop up in this area. So let's jump back out. We also have C-Bay. We have $200 right now. We can hide items we've already purchased. So we could buy, it looks like, new nodes for our programming. And then here we can buy hardware at some point. Because right now, at the very beginning of the game, everything you do is run in the cloud, so to speak. And it costs money for server time on the cloud. So you have to make your programs efficient and fast so that your server time is as low as possible, which makes you spend the least amount on your cloud usage. You'll see once we start the actual game. And then we have cat skins, because why not? So yeah, you can buy different skins for the little cat up here. And I don't know if it'll maybe make different noises when you get those, but they're kind of expensive, so it might be a while before we get to play around with those. But yeah, so let's go ahead and start our first job. And then it also has this sort of little newspaper thing that pops up with interesting facts and things throughout the game. Alright, so here's our first program we have to create. Now, I find the tutorial very unhelpful most of the time. So basically, here we are. This is the game. We've started, and there's no tutorial telling me what I need to do. And it did not tell me anything other than what you're seeing here. The very first time that I was just trying out to see what the mechanics of the game were like. But basically, so here's your nodes over on the right-hand side. These are all of your logic blocks. So we'll drag that in. Your left side is your inputs, your right side is your outputs, and if you guys have been watching my Freeways series, you'll know how much I love to talk about inputs and outputs for things, and also bandwidth, which does come into effect in this game from what I have seen. But yeah, so right now we have an else programming logic block. So basically, right here we've got a drop-down menu. So the way that you read through this particular block is your input, it reads your inputs, and then it says, if it's red, go out of this top block, else go out of the bottom block. So if we hook up our input, we will get red and blue coming into our programming block, or node, I just need to call them. We'll have red and blue coming into our node. Red goes into output 1, else, which means blue because we only have one other color, and shape, as you will see, there are many shapes that we will have. So then the else means that the blue will go out of the second output, which goes down here, to the output area, which is looking for blue, and this one's looking for red. And then over here, further on the right, this right here, says occupancy, means we have 10 blocks coming in that are red, and 10 blocks that are coming in that are blue. Over here, this wants a minimum of 8 red blocks in order to pass the level. Same down here, this one wants 8 blue blocks. And then on the far right side, we have accuracy, which sort of plays into this. So let's say if I hooked this up here, so it sent both red and blue into here, we may hit our minimum of 8 red blocks that have been put into this output, but because we've also had 10 blue blocks come into here, our accuracy will fall because it's not matching what it's looking for. So that's some of the things that you need to keep in mind. As I said, in later levels you also need to pay attention more to how long you have to complete the task, because some systems are faster and some are slower. And that's kind of also what these little boxes under the input side of the node and the output side of the node represent. As inputs come in, we can have a total of 1, 2, 3, 4, 5, 6 queued elements basically coming into our node that it can switch at a time. So once more than 6 things have entered the block, and it's a little bit slow, it's not instantaneous as you will see. Once we hit more than 6, then everything coming in comes to a stop, and it starts performing very slow with switching for its outputs. But let's go ahead and hit that run test option up there. And we can see we have blocks coming in, red's going out up there where we want them to, and then our else statement sends our blue blocks down to the bottom. And then this is where we can use our speed up time button to get through it faster. Alright, so you can see that it's going to, because that was just a test run, it's estimating it will cost us $42 in server time on the cloud to run this program, and it will take 21.1 seconds out of the 35 seconds we have available. Up here at the very top you can see where we have stats on the program that we are doing. So our servers cost $2 per second of runtime for the program. There's the total time we have to complete it. I'm not sure why estimated cost is not being entered since we already did our test run. It should have been put there. That may be a bug because this is a early access. And then here we get $300 for the reward for completing this. And because we just did our test run and we saw it was going to cost us about $42 to run this program, our reward is going to be about $260-ish. Let's go ahead and release, so you'll get a warning. So we got to rent servers. It'll tell us how much it costs us per second. We have plenty of money right now to do this, so we can just hit accept. And then it also has a little counter to show you how much money you've currently spent, and there you go. As soon as we satisfied everything on the right hand side for our outputs, it just ends it, and that's why we only have 9 of 8 and 8 of 8 instead of 10 of 8, 10 of 8, because it will end early once it is satisfied. So here's our reward screen. The Cat Cash Bank is where we get paid. We got $300. It cost us $42 to put our program into the Cat Cloud. And so we made a total of $258. Not bad. And yes, a lot of things about this game are cat-centric. As you can see right here, our email addresses are at cat.meow. It's kind of funny. But yeah, there is a lot of cat-centric things in this game. And as far as I can tell, these little descriptors that come up for the actual jobs, they really don't... They're nothing. It's just flavor text at this point because the game mechanics, as you've seen, it has nothing to do with errors in a questionnaire data or anything like that. It's literally just trying to do the logic of sorting things. So this one we need 100% accuracy. We have 33 seconds to complete it, and we get $350 for doing it. So let's go ahead and start. So now we have an expert node, an expert system node, and a trash can. You will also notice that we now have red, green, and blue squares that are coming for our inputs, and our single output is now looking for red and green squares. So, one of the things we can do here, if we go ahead and hook up our first input, we will have red, green, and blue come into our first node. It will see red and send that out, which is what we want. And then everything else which will be a green and blue squares, will be sent out on output 2, but we don't want both of those going to the trash can, and we also do not want both of them going to our output. So we need to add another expert system node. Now for this one, since we are looking for green on our output, if we put green here and attach our primary output, it will send the greens to our main output. And then we can send blues to the trash can. If you don't have, I believe if you don't have anything connected, which we can actually just try it. I believe if you don't have anything connected here, the blues will also get sent out that way. Oh no, so yeah, you can see that they fill up the output because they have nowhere to go. And then that ends up jamming the primary input. So you do need to have that connected to something so that things do not build up within your nodes. So let's go ahead and do one more test run. And this may look a little bit easy so far, but if you've played Human Resource Machine, you know that it's going to get much worse. So that's not too bad. We're going to go ahead and release it at $2 per second. And you can actually see our money ticking down at the same time as the money spent goes up. So we spent $56, we took 28.1 seconds out of 33 seconds, and we completed it. So we got 350 minus 56 gives us $294 in income. Not too bad. So once again, we've got more flavor text basically. We have we need 100% accuracy in this one. We have 35 seconds and we'll get $450. Okay, so this one is pretty easy. Oh, that's right. So this one wants us, if I had actually read the flavor text, and actually, even though I've reset the tutorials, there's actually, if I go to menu, you can reset tutorials. I've done that, but it's actually not bringing up the same tutorials because I should have had like 2 other screens by now that sort of described how to play. But anyway, so now we can do custom nodes. Here we go. Here's one of the tutorial screens. So, custom nodes. You can use programs which you've constructed while completing previous tasks. Here you can see all of the schemes made of basic nodes recursively, which are allowed to be used in this task. Custom nodes don't waste time on transferring data from one node to another. At any time you can get back to the previous tasks and rewrite the programs. For example, you may optimize them for using in the current program. Now this I've not really understood what I'm doing with it so far, but I also haven't gone much further than the next 1 or 2 levels. So I'm not really sure where it's getting these from. I believe it's from the previous 2 levels that we've done, but I'm not really sure. But anyway, they're much faster and a little more powerful. So here we're trying to get down to just red. We have red, else, divide node. So this is from our very first program where we needed to split out only red. So basically we'll hook that up there, and then everything else is going to the trash because we only want red squares. So we do a test run. You'll see that its outputs are significantly faster. Because if you remember on our expert system, which I will try to use here, hopefully it does not yell at me. Sometimes the game won't let you do custom things. If you're in a tutorial, there we go. Oh no, I guess it does come out fast. That's weird. I know at times these will slow down. But I guess not here. Okay, whatever. We know this works, so we will go ahead and hook that up and release. Nice and easy. Made $391 total. So now we have the next thing. So they've changed their database systems. We need to update our code, and it must be faster. So this one is a little bit difficult, and it's also the last one I've tried on my own. So after this, we will be in the wild. So we need 100% accuracy. We only have 18 seconds now, which is significantly less than what we have been given previously, but we'll get $530 as our reward. So we have the expert system, and we have decision tree color. So the first thing I want to do is just show you what happens here if we use an expert system. Test run. You can see it takes a little bit of time to go through all of the inputs, and it takes us 18 seconds and we only get to 2 out of 8. Now, if we switch this over to our decision tree, don't worry about this, I'll explain it in a second. I just want to show you how much faster it is. You can see that it basically can send constant data, or elements, or whatever you want to call these, squares over here, colored shapes, I should call them, because we will have other shapes later on. But you can see that it sends them in a single continuous stream, which is significantly faster than what the expert system can do. So let's move that out of the way for right now. I'm going to take our decision tree color node. Some of the names are kind of long here. We want to send out red. But then if we look at our second drop-down menu, you can see we can choose any of our 3 colors as well as any. Now, what you may think is, oh, well, you'll just do this. You'll say any, and then you'll hook up the second output to the trash can. But if we go ahead and run it, you'll see that we're getting red sent to the trash can, and actually, I don't know if it... Yeah, so you'll get red sent to the trash can in this configuration. And the reason for that is this is not an else statement. And the reason for that is that this decision tree color node looks at the inputs in this order. So it'll see a red block come in, it'll say, oh look, output 1 wants red squares. So I'll send a red square out there. But while it's processing that, it already has the next input coming into its decision area. And if it's also a red square, well, it can't go out of output number 1 because it is currently outputting the previous red square. It has not cleared the tree yet, so it has to put it down here because it's accepting any. Now, if we had put green here, for instance, all of our reds will go out of slot 1. But, as you can see, we're also getting some blues. Because now that we have this set up this way, red block comes in. Okay, we know what to do with red blocks. They go out on output 1. Another red block is there. Okay, well, output 1 is currently busy, but we can queue up a red block to go out of output 1. So then we add a, we start filling up our queue here for output 1. Oh, but now a green block has come in, so we can actually put that right onto output 2. And it fills up the very first block as it's processing it. Oh, but then what happens when a blue block comes in? Well, it's not red, but it's also not green. So it could go out of either output. So it looks for, I believe, the one with the smallest current queue, and it'll put it there, and then it'll go out of that way. So, what we want to do is we can do red, so it goes out of 1, and then we're going to have an any, which will, some of our reds will end up going out on it. So let's have another decision tree. We'll come down here, and we want to make this red. Ooh, I'm already trying to remember how I kind of did this before, because it took me a few tries. Maybe I immediately need to go into an expert system for that else programming logic. So basically, if it's red, it gets sent out. Otherwise, it's going to the trash. Now let's run this and see if it's fast enough. I have a feeling it's not. Okay, so you can see how that chokes. Because it has so many things to process. Because this is a significantly faster piece of programming that's sending in and out in a continuous stream. So we know that doesn't work, so let's get rid of these lines. We're going to need a decision tree for sure. So let's say green and blue. We know for a fact that blue is going to be deleted. No, maybe... Okay, so I'm not sure why I was being such an idiot. So this is all we needed, just 2 decision trees. So the first one's going to be red for output 1 and blue for output 2. And then, so basically what happens is red, green, and blue come in. Red will get sent out on 1, blue will get sent out on 2, and then green will go to either 1 or 2. Which is fine because we want blue and green to hit the trash can. Which we can actually put it closer just because. And then, so green and blue will hit the trash can from here. That's all good. But red and green will send out here into our second decision tree, where it sorts out red to our main output and green to the trash can, and that takes care of everything. So let's give it a test run. And you can see it does exactly what I just said, and we complete it in 14.1 seconds at a cost of $28. Pretty good. So let's go ahead and release it. I don't know why in the world I was being so stupid and blind about that. It was actually really easy. So we made $502. And now we are past where I've played so far in this game. And you can see we now have something under startups. So we're going to actually... So yeah, if we go back here to jobs, you can see everything we've done. We can go back and edit them. Illuminati Origins, okay. I do want to check out this startup though. So Tatari, Geeks, whatever these 2 things are for. Let's give it a read. So Tatari, good day. We are inviting you to join our hacker startup. We rate cheats and guides for different games, but we would like to create something very cool now. We need a program that will play and win an Arkanoid instead of the player. We know that you know a lot about machine learning, so we are inviting you to participate in our startup. So, it looks like we can invest in them. We have $1,645 so far. We can invest up to $100. And let's go ahead and join the startup. Let's see what this is all about. So the scheme created while working at a startup does not differ from a usual task one, but it can work better or worse. Your profit depends on the quality of the scheme. In startups, when you press release, your scheme starts to work automatically. Don't worry, you can get back to the scheme and change it anytime. If your scheme contains self-learning nodes, you can disable learning and test run. So that's going to be pretty interesting if we have AI nodes later on that will change their behavior. So here we go. We've got a really easy thing again. This is actually pretty similar to what we just did. So we're going to have red and green. And we need a trash can. We can do it like that. So red's going to continue on. Red. Blue. We actually need one more decision tree here. And we're going to do, green and blue. Blue, blue, green. Yeah. Yep. So that should work now. So when, oops, let me hook up our input. So let's give it a, too many nodes. Ooh. Okay. Well, let's clear that. I don't see anything that tells us what our node count is, what our maximum number of nodes can be. There's nothing that tells me. So I'm not really sure why I couldn't use those 3 that I was using. So let's go ahead and just do this and see what happens. Too many nodes. So I assume I only get 1 node then. Let me see if that'll even run. Okay, so yeah, I get 1 node to work with, which is not very helpful. I'm really not sure what I can do with that. Yeah, that's just an else. Without blue. Well, I can't do that either. Oh. So money. Money histogram shows the dynamics of weekly income. The number indicates the income received during the current week. Red column states that users brought you less money than you spent on servers that day. User histogram shows the dynamics of the number of users taking part in the startup. The number indicates the number of active users at the moment. If the number of users exceeds the bandwidth of your scheme, overload grows. The overload histogram shows the overload dynamics. The number indicates the current overload. If the overload gets massive, try to optimize the scheme. Here you can see the amount of money the company has, and if the money runs out, and the company will cease to exist. You can leave the startup and sell your shares anytime. Here you can see their current value. So a lot of stuff going on now. Launching a successful startup or successful completion of a task requires 1 day. And the end of the week, every startup provides you income. Alright, so we can see our startup over here on the left. And actually, I honestly don't know if we can complete it right now. I think we got to do maybe another job that will give us a red and blue output for our custom node, and we can slot that in. Ooh, so here we go. Now we're getting into some interesting things. So we've got a sifter, which is for shapes, it looks like. So we'll take our input. We are trying to get triangles, so we will set that to triangle, and then everything else is going to the trash. So let's give it a test run, make sure it works as expected, which it is. Although it's quite a bit slow, it's got a lot of stuff to go through. And we're not going to finish within... Ooh, we just finished within the time limit. Okay, so we can release that. And we have to wait through it again. And there we go. We took 53.2 seconds out of 57 seconds. And we spent $106. But in the end, we made $574. So now we got another thing. We only need 40% accuracy, and we have 40 seconds to complete this one. We'll get $400. So here's another newspaper. Rosenblatt's perception. First perception, machine neuron, was invented by Frank Rosenblatt in 1957. Frank created Mark I in 1960. Mark I is a perception machine that can recognize English letters by their shapes. That's pretty cool. So you'll get little things like that throughout. Oh, okay, so Mark I perception. We just get one. That's pretty cool. And then we just hook it straight up and let it run, I guess. I don't think there's anything else we could do here, so I'm just going to go ahead and release it immediately. Whoa, what? Oh, it's terrible at perception, apparently. It's sending stuff all kinds of wrong. Ooh, crap. Yeah, it has an error rate of 75%. Okay. Hold on. What? Okay, so we're gonna have to have multiple of these, I think. So, circle, square, and oh, no, here we go. Let's grab a number of these and try to reduce our error rate here. So, do something like this. And hopefully... Oh, train, I see. Oh, okay, I didn't realize that. So this is one of the things that goes by AI. So actually we don't need these because we can train it and then release it. So I think we just spent money there because that actually took money to run that. But that's okay, we are learning. So we'll do training one more time. Although I don't think the error percentage is going to go lower than 20. But it's doing much better for our... Oh no, it actually did not cost us any money. I figured to do the training it would cost us money to put this on the server. But apparently not. So now that we got that error rate down, because we trained the AI, I can recognize the shapes better, and there we go, now we completed it. Yeah, we only made $186 from that one, but that's okay. Alright, so... oh, we're gonna get a... We would have gotten a check from the startup if we had done anything, but we didn't, so we got nothing. But we also didn't have anything running, so we didn't have to pay anything. Okay. So I still don't think... Oh, here we go. Private. Mail from parents. Let's see what this says. Hello, dear. We remember what you've said, but your birthday is coming soon, so take this money and buy yourself something tasty. We love you very much and we miss you. P.S. Do not forget to put a hat on. It's very cold outside. So my parents just sent me $1,065 for my birthday, apparently. Pretty cool. Thanks, guys. Go back. I'm gonna jump back into this real quick and see if we have anything new. Take a look at custom nodes. No, we don't have anything here. Yeah, we need 100% accuracy, I think. That's what it looks like. I want to know what happens if we hook it up like this. I don't know if that's acceptable or not. So let's go ahead and release that. It should bring us income even though it's not 100% accurate. But hopefully at some point we can go back and make it a little bit better. Let's go on to job number 6, text recognition, or text recognizing. So we are aware that you are able to create a text recognition system based on the Rosenblatt perception. We need a similar system. You must teach it to distinguish vowels from consonants. Task is simpler, but more accuracy is required. So we need 50% accuracy. We have 52 seconds, and we'll make $550. So we'll take another Mark 1 perception, and we'll throw... Here we go. Now this is where we're going to need a couple of things here. Throw this down here, I think. Yeah, maybe we don't even need that, so we'll just do that. that, and that, and that. So let's go ahead and train this and see how it does. Not bad so far. Getting about 75% accuracy when we needed 50%. This error rate still was coming down a bit. But we ran out of time because we need 18 and 30. Let's go ahead and train this again and see what happens. So it's taken a long time to fill up that bottom. And we're still failing, even though we've got it down to 20% and 20%. So we may need another perception in here. I'm gonna hook that there, hook that. That. Oh, I see. Okay. Alright, this might work now. Let's do some training. And I screwed it up. Stop it. So we need to get some more shapes into this bottom area. So let's go ahead and stop that. Change that to there and do training. Might just make it this time. Yep, there we go. So now we can release it. Because there's an error rate with this, we have to have multiple sets of the error rate to help reduce the overall error rate. But also because this one's 30 and this one's 18 total pieces of blocks, elements, whatever you want to call them. We want to have in this first block, because we can't have it going to multiple... we can't have multiple lines from the same output. We want to send both squares and triangles towards this one that needs more blocks total. That way the ones that are correctly matched will be getting down here faster. And more of them will be getting down there total. I thought we released this. Why didn't it go on? Oh, maybe we ran out of time? Oh yeah, what? Why is it slower now? Okay. Well, there's not much I can do about that. Okay. Maybe I need to use one of these? Although it should be the same thing. Come on, why won't this work? Wait, I wonder... No, I don't think it's faster if I don't train. Well, that's stupid. We were able to complete it during the test run, but now we can't. I'm gonna put one more in here. I don't know if that's going to help us at all, but let's see what happens. It's sending so many circles down here. I don't get it. Well, we got it to work once, and now it's having problems. Let's see. Well, first of all, squares need to be going down here, not up. So that's not helping. Okay, now we should be able to complete this pretty easy, now that I actually have the things going to the right places. Yeah, there we go. Finally got past that one. But we spent a lot of money because I tried to release it a whole bunch of times without it being successful. So we ended up losing $240. It's not very good. Alright, so for the next one, we've already bought Christmas trees for the holiday. Friends said that you can calculate when the peak demand for the goods will be. Okay, whatever, doesn't matter what it says here. We need 100% accuracy. We have 18 seconds and we'll get $450. Darkest years of machine learning. In 1969, Seymour Papert and Marvin Lee Minsky, Papert, I'm not sure how to pronounce that, it looks like a French name, a book called Perceptrons. In this book, they talk about math constraints of the first perceptions, Perceptrons, Zohr problem. This book has shifted the scientific interest and subsidies of the U.S. government organizations and slowed the machine learning for almost 30 years. The expanded version of the book was released in 1987, containing the chapters that disprove the statements from the critical remarks made since 1969. Okay, sounds pretty interesting. Okay, this one's an odd one. So we're just gonna have a decision tree. Any... Whoops, we should do any on top, green. And actually, that's all we should need. Oh yeah, that's real easy. Go ahead and release that. $423. Pretty easy. This one needs 100% accuracy. We only have 10 seconds. But we'll get 450. Ooh, this is a new node. Oh, I didn't even see that before, the question mark. So a load balancer. This block routes elements in the socket with the least overload. That should say with the least overload. So that's a little spelling error there. Warning, this block requires additional server cost. Okie doke. And then in the real world, a load balancer is a device that distributes network or application traffic across a cluster of servers. Load balancing improves responsiveness and increases the availability of applications. Yep. Sure does. That's exactly what it does. So yeah, we just have red in, red out, and it literally is basically just a splitter. Oh wow, that's nice and fast though. I like that. So that's a pretty cool little block we're going to have now. Go ahead and release it. Made $430. Okay, so this next one, need 100%. We have 15 seconds. 550 is the reward. So let's have a couple splitters here. We need... Nope, that's actually enough. Bam. Oop, I lied. We do need one more. Let's just go ahead and release it. We know it's going to work. There we go. That's what I'm talking about. $454. 100%. 25 seconds. 750 is the reward. Alright, so let's go back over here to our custom nodes. And only red. Oop, nope. We should have an only red fast, I thought. Okay, I guess that is no longer there. We used to have an only red fast. But we do have this. That's a load balancer. Let's get a number of expert systems here. We only have 25 seconds, so we're gonna need quite a bit of throughput. Come on, click it, there we go. We may need more than this. Yes, those are extremely slow. They take 1 second to process. So, let's clear this real quick. I'm going to take a look at these custom nodes we have. So, 2 parallel. I don't remember what that does. Put a trash can. Let's test it and see what it does. Oh, it's okay. Yeah. We can clear that. Go back to custom nodes. So we can do this 4 parallel here. Okay, let's give this a run and see what happens. Oh, it would help if I hook this up. Alright, let's try that again. Oh, that actually worked pretty well. Okay, well, that's pretty cool. Let's go ahead and release it. $20 a second. Ooh. Costs quite a bit to run that. It took us 10 servers to run that, but we made $490, so not too bad. I still don't think there's much we can do with that startup. So we can look here, our weekly income right now is negative 93. It's not very good. Let's try and patch it. Let's try and see if there's anything new we've got in the custom node side. So we can do all green, only red. There's our only red. Oh, that's right. We can't. Man. And we only get 1 node. Oops, release. Wait, what? Oh, we can have more nodes now, apparently. Okay. So... Okay, so I think that's better. Can we... Yeah, we can release it like that. Okay, let's put in a 3rd decision tree then. Oops. Let's grab that. Go into there. Alright, that should be much better now for our startup. And I think actually I'm going to leave this episode here. And if you guys did like this new game, please let me know in the comments. I'm probably going to play a few more episodes and just kind of see what the game is like. I do want to give a shout out again to Oleg Chumakov from Luden.io for reaching out and giving me a code to this game so I could check it out and see what it's all about. It's pretty interesting so far. Like I said, it's a lot like Human Resource Machine, which was a game I was very into for a little while, a couple years ago when it came out. Not bad so far. I mean, you can obviously tell it's in early access. There's been a few little things. And maybe seeing this video, if Oleg sees this video, he'll go in and fix them. Who knows? So hopefully you guys enjoyed it. If you did, hit that like button, subscribe, share this with your friends, and I'll catch all of you in the next one.